and the ending point of a loop is called as a node. Amplitude, wavelength and velocity are similar. It is due to the superposition of two progressive waves starting and ending regions of the loop where the particles are at rest. The stationary wave is called as a loop. Therefore, hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In my yesterday's session on waves, we discussed a very important topic, something called as Newton-Laplace formula for velocity of sound in a gas and the principle of superposition of waves. In my today's class, we will understand a very, very beautiful concept called as standing waves, or they are called as stationary waves. So therefore, today we discuss a very important topic, what we call as standing waves. And these standing waves, they are also called stationary waves. So my first understanding here is how standing waves or the so-called stationary waves are formed. I consider two progressive waves, waves which travel continuously in the medium in the same direction with the constant amplitude. We call them as progressive waves. Two progressive waves of the same amplitude, same wavelength, same time period, velocity, but traveling in opposite directions in a medium. See, beautiful conditions, Salva. This is the first progressive wave. This is the second progressive wave. I assume they have the same amplitude, the same height, same wavelength, same velocity, amplitude, wavelength and velocity are similar, but they are traveling in opposite directions. When they meet each other, yesterday we studied, they superpose, they interfere, they cross over each other to give a special type of wave called stationary waves or standing waves. So when they meet at a certain point, now what happens? A special type of wave is formed. This is due to the superposition, due to the interference of two progressive waves traveling in opposite direction. And they are beautifully called standing waves or stationary waves. What is the reason? Very simple. A stationary wave, as the name itself says, cannot proceed in a medium. It can just expand or shrink, but it cannot proceed in the medium. It is stationary. It simply stands in a medium. It cannot proceed in any direction. Therefore, it is called as a stationary wave. And a stationary wave can either be a longitudinal wave or it can be a transverse wave. So, Parikshadal keltare, how is a stationary wave formed? So, for which two progressive waves of the same amplitude, same wavelength, same velocity should be traveling in opposite directions. They superpose each other, they interfere each other, and the resulting wave is called as a standing wave, stationary wave. It cannot proceed in the medium. It can expand or shrink, and it may either be longitudinal or transverse in nature. Now, this is the diagram of a stationary wave. Here, each component of the wave is called as the loop. Each segment of the stationary wave, each component of the stationary wave is called as a loop. Therefore, we will understand the characteristics of stationary waves. The first characteristic says, very important, at certain points in the medium, the particles are permanently at rest. At certain particles of that wave, the particles are permanently at rest. And those points are called the nodes. Very important. ನೀವು diagram na observe ಮಾಡಿ. At these points, if you observe, this is a loop, and these points, the starting and the ending point of a loop is called as a node. Here, the particles are completely at rest. On the nodes, the particles are at rest, which means at the nodes, the amplitude of the particle is 0. They are at rest. They don't vibrate. So their amplitude is 0. So at the nodes, the particles are permanently at rest. They don't vibrate, which means their amplitude is 0. Now, certain points in the medium, the particles vibrate with maximum amplitude. Certain regions in that loop, so-called segment, the particles vibrate with maximum amplitude, and these points are called the antinodes. Concept of nodes and antinodes. So if you observe, this is the portion of the loop which is called antinode. What is the significance of the antinode? The particles vibrate with maximum amplitude. Nodal enagutte, particles are at rest, they have 0 amplitude. Antinodal enagutte, particles vibrate maximum and they have maximum amplitude. Third one, very important, the position of the nodes and antinodes are fixed. Nodes ಹೇಳಿದ್ನಲ್ವಾ, starting and ending regions of the loop where the particles are at rest, antinodes where the particles vibrate with maximum amplitude and it is fixed. Fourth, very, very important, since they are stationary waves, the so-called standing waves, there is no flow of energy across any section of the medium. Very good comparison with progressive wave. We always told a wave is a carrier of energy, carrier of momentum. But a stationary wave never moves. It never proceeds in the medium. Therefore, there is no chance that it carries energy in the medium. So we say there is no flow of energy across any section of the medium. At the nodes, velocity of the particle is 0 because it is at rest. At antinodes, velocity is maximum. Nodes, the particles are at rest. They are stationary, so they have to have 0 velocity. Antinodes, they are vibrating with maximum amplitude, so their velocity has to be maximum. And very importantly, distance between two nodes in a loop is lambda by 2. So distance between any two nodes is lambda by 2. Distance between an antinode and a node is lambda by 4. Distance between two successive nodes, lambda by 2. Distance between an antinode and a node, lambda by 4. And these are the characteristics of a stationary wave. So now, on hearing to the characteristics, the features of a stationary wave, we will compare a stationary wave with a progressive wave. For 3 marks, this is a very important question, students. Comparison between progressive wave and stationary wave. First point of comparison ಏನಾಗಿರುತ್ತೆ? Definition itself. A progressive wave is set up by continuous vibrations in a medium. It moves continuously in a medium, where a stationary wave is due to superposition of 2 progressive waves traveling in opposite direction. Progressive wave ಯಾವ ರೀತಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? Continuous vibrations of particles in a medium. ಅದೇ ಸ್ಟೇಷನರಿ ವೇವ್, 2 ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ಗಳು ಒಂದೇ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡಿದಾಗ ಸೂಪರ್ಪೋಸ್ ಆಗಿ ಸ್ಟೇಷನರಿ ವೇವ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಇಟ್ ಈಸ್ ಡ್ಯೂ ಟು ದ ಸೂಪರ್ಪೊಸಿಷನ್ ಆಫ್ 2 ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ಸ್ in opposite direction. Since a progressive wave moves, there is flow of energy in the direction of propagation. Since stationary waves are at rest, there is no flow of energy. Here no particle is at rest. Progressive wave, all the particles have same amplitude, no phase difference, no particle is at rest. At antinodes, we saw in a stationary wave, particles are at rest, they have 0 amplitude. All particles vibrate with same amplitude. Here amplitude is 0 at nodes, maximum at antinodes. Progressive wave, as the name itself says, they travel forward with some velocity. These waves do not travel. So these are the basic points of differences between progressive wave and stationary waves. A few good definitions which I have already done in oscillations. Free oscillations. ನೆನಪಿದ್ಯಾ? damped, free, forced ಅಂತೆಲ್ಲ ಓದಿದ್ವಲ್ವಾ? What is free oscillations? If a body oscillates with its natural frequency without an external force applied, it is free oscillations. Forced oscillations, if the body is made to oscillate under the influence of an external force, its frequency is now with respect to external aid. It is forced oscillations. Resonance, frequency matching condition, natural frequency of oscillations matches the applied frequency, then we say resonance is achieved. So in today's class, we have understood a beautiful concept of stationary waves. Next, we will study the vibrations of air columns. Until then, have a nice time. Thank you.